Hello, mentors. Welcome to meeting 7. And we're in part 2 in Salva el gato, so save the cat. So remember, this is after students have done the basic fire trucks, in which there are just 2 fire trucks, and you want to find distances to decide who would get first. So we go deeper now. We still have 2 trucks, and we can still ask which gets there first. So it's similar, part A. We'll see that 4 and 5 are the distances. You can see here 4 and then 5. These would be paths, not unique. And then what we have, so A would get first. Because 4. B takes 1 unit longer. So part B is place a new truck that's 6 units away from the cat. So this is an interesting mini exercise because it's kind of inverse, right? It gives you the units and you have to see where would it come from. And then this is important because they would see that it's not unique solution. And this is starting to look like a circle. You don't say anything, but in the next task, since you did this exercise, it will connect when they will actually draw a circle, which is a rhombus, right? Anyways, let's go back. So B would be place a truck 6 units away from the cat. So if they do it in this bounded grid from the workbook, there's only these 6 choices. Let's take a look. 1, 2, 3, 4, 5, 6. This is also 6. You don't need to even count it. And the reason would be if I go down here in this truck and you go left with this truck, they are the same distance apart from the cat, so they must be actually the same distance. It's a cool reasoning without even needing to count. This is also 6, right? And this would be also 6 because if I go up and I go left with these 2 trucks, they meet. And so they're equally far away because then they have to, uh, go forward the same number of units in the taxi cab metric. So that's the reasoning why we have these lines, right, of 45-degree angles, right, to make same distance from some target. This would continue here, but it's out of the grid for a distance of 6. It would continue kind of here and then go up, up. So this is actually inside the grid. So notice if that students use the geoboard or a bigger grid, and depending on where they place the cat, they may be able to see more trucks that are 6 units apart, lots of trucks. So you can try to find out how many, and that could be a good challenge. Like if we have an unbounded grid, like as big as we want, we can go up or left as far as we want. How many trucks would we see? And there's quite a lot, right? So you can see here, it's a diamond, but it's chopped, right? It's cropped. Part C is counting, a very good exercise in counting. How many routes can truck A take to reach the cat as fast as possible? And how about B? So they may think that there's only one route first because of the Euclidean distance. That's the case. But in taxi cab, we have typically more than one route. So of course, if the truck were here, there'd be only one path, or here, anywhere that's just a line because they just need to go forward and that's it. But taxi cab is different. So for truck A, probably one would start with truck A. There's 4 different paths. Let's see what they are. This would be one, right? This would be the other one. This would be the other one. And finally, this would be the last one. Just go left, 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 and go that at the end. And you can see that there's no other paths. So you could think of this as a 3x1 rectangle, right? In which the corners, the opposing corners, are the points where you want to travel from one corner to the other one. And we have somehow said or concluded that when we have a 3x1 or 1x3 rectangle here in taxicab, there's going to be 4 paths. Again, 1, 2, 3, and 4. So that piece of knowledge can come handy for doing truck B. So for truck B, of course, it's now a 2x3, so larger rectangle. And so it becomes more messy. And students could start counting maybe without any systematic way. And that's fine at the beginning. But then they're going to maybe count twice or forget to count some because there's, there can happen different things. Here it was easy because there was just one range of movement vertical. So once you went down, you had unique solution, right? You only wanted to go left. That's all you could do. So for B, here's one illustration. There are several ways to solve this task, but here's a tree, counting tree that we add. And so here's the start. So truck B, in order to get closer to the cat, can only do two things, left or go up. That's all they can do. Otherwise, they get far away and it's not a minimal path. If you go down here to B, then you're here in this point. Notice that you get a 3x1 rectangle. And so you don't even have to count because you already did truck A. And truck A, you know that it's going to be 4 paths. So these would be the paths. The first one, second one, third one, and fourth one. So it's kind of a repetition. So that's 4. And then if you go up, then you would ask the simple question. If you are in a 2x2 square, what's the distance from a corner to another corner, opposite, right? In taxi cab geometry. And so you could count it, or you could even break it a little more. If you go up, you're in a 2x1. And if you go left, you're also in a 2x1, right? It's exactly the same configuration, essentially, in terms of counting. Now it's easy to count here. It's just 3 paths, 1, 2, and 3. Very similar to the 3x1. So it's just going to be one more than the length, the longer length. And 3 plus 3 is 6. So this would give us 6 different paths. Notice that these have to be different because you went left and you went up. So these paths that we're counting here are totally different. Same for this, because in these 4 paths, we started going left. 4 plus 3 plus 3 is 10. So we get 10 paths. This has the advantage that you could then challenge your students more and say, okay, here's B. What if we had a new truck C here? How many would it be? And so you could also make a decision tree or a counting tree, right? A cases tree in which you would say, okay, here's the start. This is a 3x3 square where the corners want to meet somehow. And then case 1 is if I go here, I don't need to do anything. I know that it's going to be 10 different possibilities because I am in a 3x2 case, right? I just did it here. But if I go up, case 2, guess what? It's the same. It's a, 2x3. Here was a 3x2 or whatever, but it's exactly the same counting, right? So magically you would get 10 plus 10, so 20 paths without even counting. So of course, this is induction or recursion. You don't have to use these fancy words. And see how far you can push your students to get to this generality, because that's what it's all about, right? In math, looking at these patterns and realizing, wow, we are counting without counting because we already counted, right? In the simpler case. So that's Save the Cat or Salva el Gato, and have fun with this activity. See you in the next video. Goodbye.